Welcome back, students. And today we're continuing with the environmental effect on phenotypic expression. We had mentioned about the internal environmental factors and how they can influence the phenotypic expression. And now we're going to talk about the external environmental factors. As some examples, we are taking drugs, chemicals, as well as temperature and light. And we're going to explore how they could affect the phenotypic expression. Firstly, I would like to talk about the chemicals. The influence of chemicals on gene expression was being explored in 1907 by Stockard, as he noticed that cyclopean fish embryos, when they were being fertilized in seawater which contained 6 gram of magnesium chloride, it was being found that in the presence of magnesium chloride, these embryos, the fish embryos, were being developed to one-eyed embryos. And usually the fish normally has two eyes, but in the presence of a particular chemical called magnesium chloride, the embryos had developed into a one-eyed embryo. So this was a first instance at which it was shown that chemicals could influence the expression of some particular genes. And like that, we have different examples of different chemicals. Another example of a chemical induced gene expression was mainly being found when supplemental oxygen administration caused blindness in the premature infants. Previously, in the 1940s, it was noted that when the children were being born prematurely, the doctors they found that if the increased oxygen level was being given to the infants or the prematurely born infants, they were being found to have a normal rhythm. Okay, they have a normal breathing pattern if they were if they were given increased oxygen levels. And ultimately or unfortunately, we could also find that when such high oxygen levels, the normal oxygen which we have, if it was given in a high level, it was giving what? A normal breathing rhythm. But when they were being supplemented at a level higher, it was being found that this oxygen administration could also cause blindness in the premature infants. And moreover, it was being found that so, retinopathy was also being found to be associated among for the premature, that is in the premature infants. So, though oxygen is increasing the breath rate, or a normal breath is being attained even in the premature infants when they are given good oxygen, that could what? That increased oxygen could trigger another gene which is responsible for the what? The retinopathy or the damage of the retina. Okay, and even if you give low oxygen, that would also be very critical because that would also cause the brain damage as well as a mortality in the premature infants. So a normal chemical such as oxygen or a gas such as oxygen, that also has a role in triggering some genes as well as also triggering other genes. And the concentration of the chemical is also being found to be very critical. If you have a very low oxygen to a premature infant, what happens? The brain damage can happen. That is the reason why even during the delivery time, we say that of course the baby should be given a good oxygen saturation level. And if the baby is getting suffocated within the mother's womb, we immediately do a cesarean and take the baby out. That is, even if it is a very little oxygen, it is harmful for the baby and that could cause the brain damage. But if you go to give a higher level of oxygen level after the baby is being born prematurely, in that case, other genes which are being responsible for retinopathy could be, or the retina damage would be triggered and the blindness would be resulted in the premature infants. So, what I would like to say is normal chemicals such as oxygen itself is here playing a role in the phenotypic expression of a particular gene. And of course, we always now try to give an optimum oxygen supplementation for the infants. Coming to the next factor which we have is the drugs. In the case of drugs, various drugs, now for example, which I'm talking about here is thalidomide. It is a sedative and anti-emetic as well as a non-barbiturate drug, which was first manufactured and marketed in the mid 1950s. And this did not have any bad expression on the development in healthy adults, and it was being used profusely during the 1950s. But it was later that it was being found that this has a detrimental effect on the developing fetuses. Not until 1961, Australian researcher William Beckbred and German researcher Lenz, they independently reported that thalidomide was a teratogen, it was associated with the birth defects. And other studies also showed that thalidomide would also cause neuropathies or the neural damages, and the drug was withdrawn too late, and approximately about 8,000 to 12,000 infants were being killed by during this time, and that would also result in the stunted limb development in various infants. Okay, and interestingly, you can see that though thalidomide is dangerous for the embryonic development, this drug is also being used even today, but is in certain cases, now for example, to treat cancers as well as in the treatment of leprosy. Also, we are using this particular drug thalidomide. So what do we have to conclude over here? Different drugs could affect different gene expression levels, and the time at which it affects would also be varied. Now, if you go to give thalidomide as a sedative in adults, probably what happens? The gene expression is not that much affected. But if you go to the infants or the fetuses, sorry, if you go to the fetuses, it is detrimental and it would affect the there is a proper development of the fetus, and it would result in various birth defects. This is just one example of a drug which I have quoted here to get an understanding of how drugs could influence the phenotypic expression. Now, if the limb is not being developed, that is also a phenotypic expression, which is as a result of the differential expression of a particular gene. The next factor which we are going to discuss here is in the case of temperature. This is a quite interesting feature. If you can see that in a crocodile's egg, okay, if a crocodile's egg is incubated at a particular temperature, it would result in the formation of a male crocodile, and if it is incubated in a different temperature, it will express and it will result in the formation of another sex. So much important is the case of temperature in the development of an embryo in the case of certain organisms. Another good example which I would like to show here is the Siamese cat, which is it has been found that it codes for a gene which has been found to be temperature sensitive. And this enzyme, it namely causes a darkening of the cat's fur, uh, especially in the cooler parts of its body, such as the tail, feet, ears area, and around the nose. The gene is being expressed more where at the extremities where it has been found to be more cool. And at the temperatures, at higher temperatures, the gene gets inactivated. The gene which has been coding for the pigmentation. Okay, the pigmentation causing gene is at the regions where it has been found to be high temperatures. It has been found to be what inactivated, and at the extremities or the body parts where there is lower temperatures, the pigmentation causing gene is being expressed, and as a result, it looks like the tail as well as the extremities of the cat will express the pigmentation. Now, a similar case is also being found in the case of the Himalayan rabbits, and they carry a C gene, which is required for the development of pigments in the fur, skin, eyes, and all that. And it has been found that this C gene is inactive above 35 degrees centigrade, and it is maximal active at 15 to 25 degrees centigrade. So coming to most of the organisms, the body temperature is being found close to 35 degrees centigrade. So at the regions at the regions of the body where the temperature is being found close to 35 degrees centigrade, the C gene will become inactive. Now, if you go to look at this rabbit over here, if you go to consider these parts, the white parts, what happens? The heart and all the organs are working there more, and as a result of metabolism also, the heat generation has been found to be higher. So at the middle portion, okay, not the extremities, what happens? The metabolism rate has been found to be higher, and as a result, the temperature generation also, or the heat generation, would happen, and thus, in those regions where the white fur is being found, the C gene is getting inactivated. But coming to the extremities, the more important organs are not that much present, which like metabolically active organs, or the heat generation normally is being found to be less in the extremities. And at the same time, you know that extremities are the ones which directly get exposed to the environmental cold. And so the extremities of these rabbits are also being found to be of lesser temperature, and as a result the C gene gets activated and it forms pigmented fur at the extremities. Now this is uh, what is it? A rabbit which is being grown at a temperature about 30 degrees centigrade, and it does not have any fur fermentation. Okay, that is, the temperature has been found to be uniform here, and here what happens, it is kept, it is incubated. Now this rabbit which is kept at the right, it is reared at a temperature above 30 degrees centigrade. Okay, it's kept in a cage where the temperature is always being maintained at 30 degrees centigrade. So in such cases, what happens? The temperature both at the extremities or throughout the body, it is having a temperature above 30 degrees centigrade, and the C gene is getting inactivated, and you will see that they would never have pigmentation even at the extremities. Now another factor which I would like to explain is the light. Light can also influence the gene expression, and you can see in the case of butterfly, the wing development as well as the growth is being influenced by light. In 1917, Thomas Morgan, he conducted studies in which he placed the Vanessa urtica and Vanessa eo caterpillars under red, green as well as the blue light, and he found that the other kept and the other caterpillars, they were kept in the dark. When the caterpillars were developed into butterflies, their wings showed dramatic differences. That is, when they were being exposed to red light, they resulted in intensively colored wings, while the exposure to the green light resulted in dusky wings, and blue light as well as darkness led to the paler colored wings. And in addition, the it could be found that the Veneza urtica butterflies, red under the blue light, and Veneza eo butterflies, red in the dark, were larger than the other butterflies. So the growth as well as the wing development or the wing coloration is being found to be influenced by the light also. It is not the same for everyone, but to some level, in certain organisms, light is being found to influence the gene expression. Now, we also have to talk about the environmental triggers which could influence the gene expression also. They could include stress, physical and mental abuse, diet, exposure to toxins, pathogens, and radiations, etc. And even many cancers are thought to have an environmental component. We know that, for example, a person who's always getting exposed to a radiation, that in such people, probably the cancers can be triggered. I would like to quote an example over here. In Kerala, where there is thorium rich sands, okay, there is in a region called Chavara where there is thorium rich sands. What happens? The level of radioactivity of those sands is being found to be higher naturally because it contains uranium also in traces in the sand. And so the people living in that particular area are always exposed to radiations, and this could trigger the oncogenes in them. And it has been found that in that particular area, or the people who are living in that area are being found to be more prone to cancers because of the exposure to radiations. So the oncogenes gets triggered in them by the exposure to radiations. And also you can see that even if uh, a high level of stress is being found in children. Now, in the case of pregnant women who are being exposed to high level of stress, it has also been found that the babies would get a less high, small level of not a high, a small level of autism associated with it if the mother is being exposed to high level of stress in some cases. And you can also find that environmental conditions could also trigger asthma. So, like that, various genes which could remain silent could be triggered by environmental triggers such as stress, physical and mental abuse, diet, exposure to toxin, pathogens, as well as radiations. And you can see that even when you consider the twins, the homozygous twins, okay, sorry, I meant the twins, which are not the identical twins. I meant identical twins. If you go to consider the identical twins, they would be having the same genotype itself. And but what happens is when they are being exposed to different environmental triggers, the level of their gene expressions would be found to be different. So these are about the various factors which could influence, the various environmental factors which could influence the gene expression and finally influence the phenotypes. I hope you are clear with this. With this, we come to an end, and thank you for your attention.